Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC B1825, is a slide pulse error for Honda Accord models from 2008 to 2012. This error indicates that there has been no change in pulse for a duration of 1 second while operating the power seat adjustment switch. The power seat system allows for various adjustments to enhance driver and passenger comfort, and it is critical for maintaining driving ergonomics. The issue typically resides within the seat control mechanism, which is electronically controlled through the power seat control unit. It is crucial to understand that DTC B1825 may not always indicate a fault within the power seat components themselves. It can arise even when the system is otherwise functioning correctly. In this troubleshooting guide, we will outline the necessary steps to diagnose, locate, and remedy the potential causes of this code. The DTC B1825 pertains to a malfunction in the power seat adjustment system, specifically relating to the slide mechanism. The power seat adjustment switch is responsible for initiating the movement of the seat, allowing it to move forward or backward. The slide motor, connected to this switch, facilitates the physical motion of the seat. Meanwhile, the position sensor plays a crucial role in relaying the current position of the seat back to the power seat control unit. This set of components is typically located under the driver's or passenger seat within the Honda Accord. Problems often occur if the switch is held for too long after reaching the full travel of the seat, even if the system appears to be operational. Consequently, proper diagnosis of this error must begin with understanding the interaction among these critical components. Several potential causes may lead to the occurrence of DTC B1825. First, a malfunction of the power seat adjustment switch itself could result in erroneous signals being sent, leading to the slide pulse error. This switch could either be defective or experiencing intermittent connectivity issues. Additionally, failure of the slide motor can lead to inconsistent operation, which can trigger this DTC. Lastly, wiring problems, including broken wires or faulty connectors, could inhibit adequate communication between the control unit and the slide motor. Moreover, thermal stress and wear and tear over time could compromise the included wiring harness. Each of these causes must be investigated thoroughly to ensure all components function correctly. When the DTC B1825 is present, one might observe specific symptoms that indicate malfunction within the power seat system. Users may experience difficulties with seat movement, where the seat may stop moving entirely or operate erratically. This inconsistency presents an uncomfortable driving situation and prevents the driver from safely achieving the optimal seating position. The error code itself will also display on the Honda Diagnostic System, HDS, prompting further investigation. Additionally, depending on how the power seat adjustment switch is activated, intermittently operating it may provide varying results, further confirming that an underlying problem is triggering this code. Recognizing these symptoms is vital in diagnosing whether the issue lies within the switch, the motor, or connected components. To initiate the troubleshooting process for DTC B1825, the first step is to clear any stored diagnostic trouble codes with the Honda Diagnostic System HDS. The HDS is an essential tool that automotive technicians use to retrieve and clear DTCs effectively. By resetting the system, it allows for a fresh start in monitoring the vehicle's performance. This ensures that no lingering DTCs from previous errors interfere with the current diagnosis. Clearing the codes will also help identify if the B1825 is a persistent issue or an intermittent one. Once cleared, the system will return to an operational state, enabling you to proceed with further diagnosis and testing. The next step involves turning the ignition switch to the lock position, then immediately returning it to the on position. This action helps reset the onboard systems and prepares them for further operations. Engaging the electrical systems in this manner can also help in recognizing any issues that need to be addressed. This reset confirms that the system is fresh and can assist in detecting current errors effectively. Proper ignition operation is crucial for ensuring that all electronic systems, including the power seat setup, are responding correctly again. This step acts as a bridge between the clearing of codes and exercising the power seat functions. Following the ignition reset, you need to operate the power seat adjustment switch for several seconds in both the forward and backward directions. This action is vital as it stimulates the power seat's operational capability and translates into real-time feedback for the seat position sensors. For the B1825 code, it is essential to carefully observe the seat transition. If the switch is held longer than 1 second after reaching its limit, this may trigger the code, even if all components are functional. Such testing reinforces understanding system interactions and ensures fluid movement capability. Document and note responses as you engage the switch to identify if the DTC reappears. After operating the power seat adjustment switch, the next step is to once again check for diagnostic trouble codes using the HDS. This action is critical to verify whether the B1825 code is persistent or if it was a temporary issue previously resolved by clearing codes. If the DTC is still indicated, it confirms that a fault exists within the power seat adjustment system that requires further investigation. However, if it is not present, this suggests that either the system is currently functioning correctly or the issue is intermittent. Any observed DTCs at this stage guide subsequent troubleshooting efforts toward more specific areas of interest in the power seat mechanism. In this step, you will check the HDS for the presence of DTC B1836 along with B1825. The importance of this lies in determining if there are multiple faults coinciding with the original issue. The DTC B1836 relates to the power seat adjustment system as well, and typically indicates a malfunction associated with a different component. If B1836 is also indicated, it signifies another issue that must be diagnosed separately. Skilled technicians often troubleshoot codes sequentially to ensure comprehensive repairs, addressing all points of failure in the system. If B1836 is noted, you will proceed to its dedicated troubleshooting guide for a complete assessment. The next crucial step is to check the HDS for any additional DTCs, specifically looking for codes B1826, B1827, and B1828. Each of these codes is related to specific failures within the power seat adjustment system, often linked to continuity issues in the various connectors and motors. If any of these codes are present, they indicate further complications that require more in-depth analysis and understanding of the system. Resolving these additional DTCs can lead to a far more holistic understanding of the malfunction at hand. Once identified, the necessary steps should be followed to address these specific error codes and rectify issues that may interact with B1825. At this juncture, you will again turn the ignition switch to lock and back to on. This repetition ensures that the systems reset and prepares them for further checks. It reinitializes the electronic systems, confirming whether they are adequately responding to input commands. Consistency in conducting this step is paramount, as it mitigates the risks associated with unreliable input signals during testing. This will allow you to carry out functional checks of the power seat adjustment system without risking operational anomalies. Upon completion, you can then proceed with testing the slide switch operation in the next steps. In this step, you will operate the slide switch for a duration of 2 seconds to assess the slide motor's performance. It is essential to observe the slide motor's operation closely while doing this, as any irregularities can confirm suspicions about a potential failure. Smooth running of the slide motor indicates that components are functional and communicating correctly. Observing the operation provides vital insights into whether the slide motor has any internal issues. If it runs smoothly, as expected, it confirms that the initial mechanical and electrical systems are functioning correctly. Conversely, if it does not run as expected, this indicates that further investigation is warranted. After confirming the operation of the slide motor, the next action requires turning the ignition switch back to the lock position. This is necessary before making any additional checks, particularly those that involve disconnecting electrical connections. Locking the ignition ensures that no unintended electrical signals affect the components while you are testing or inspecting them. It also safeguards against short circuits, which may arise during connection disconnecting or connections made while the vehicle's systems are powered. Observing this step reinforces the importance of safety procedures while handling electrical components within automotive systems. In this step, you will disconnect the power seat control unit connector B, which has 40 pins. This action involves safely extracting the connector without causing any damage to the pins or the wiring harness. The power seat control unit is vital as it regulates commands sent to the power seat motor and monitors feedback from sensors. Proper disconnection is critical to avoid shorts or other electrical faults. After disconnection, further checks for continuity and potential irregularities can be carried out without interference from the control unit. This process is an essential part of troubleshooting, as it isolates the control unit from the system for thorough inspection and testing. Next, you will disconnect the slide motor/position sensor 6-pin connector. This connector links the power seat control unit directly to the motor and position sensor. The purpose of this step is twofold: to ensure safe testing conditions and to isolate each component for testing continuity. The slide motor and position sensor relay information back to the control unit about the current seat position, and thus any issues related to them must be assessed independently. Disconnecting these components allows for more accurate troubleshooting without the influence of external factors. Also, ensure proper handling of the connectors to avoid any mechanical damage that might affect future performances. This crucial step involves checking for continuity between specific terminals in the power seat control unit connector B and the slide motor/position sensor connector. You will need to measure continuity between terminal 11 and terminal 29 of the 40-pin connector, along with terminal 1 and terminal 3 of the 6-pin connector. Continuity testing confirms whether there is a complete electrical path between the in-sync components. If continuity is confirmed, the wiring and connections are intact, and the components are communicating effectively. If continuity fails, it often indicates that there may be a problem with either the wiring harness or the connectors. Ensuring continuity is essential for diagnosing issues in complex electrical systems. After completing all necessary repairs related to DTC B1825, it's crucial to conduct final verification through extensive testing. Recheck the HDS to ensure that the previous DTC is no longer displayed. Additionally, operate the power seat several times to confirm smooth and accurate movement in response to switch inputs. This step assures that all connections and components are functioning well together, presenting a complete and efficient power seat operation. If successful, It indicates the likelihood of issues relating to connectivity or component failure have been addressed effectively. This verification provides peace of mind, confirming that repair actions were correctly executed and that the vehicle is safe to return to the owner. To mitigate the risk of encountering DTC B1825 or similar issues in the future, regular inspections of the power seat adjustment system are highly recommended. Preventive maintenance can include checking the power seat adjustment switch for any signs of wear and ensuring that the wiring harness remains intact without shorts or fraying. Additionally, ensuring that the motor is functioning freely and efficiently will enhance its longevity. Keeping moving parts well lubricated and free from debris can also assist in smooth operation over time. Regular upkeep not only averts future breakdowns, but also promotes optimal user experience in the vehicle, ensuring that adjustments are seamless and reliable. By being proactive, you extend the life of the seat adjustment system while enhancing overall vehicle performance. In summary, addressing DTC B1825 requires a cheerful yet methodical approach to troubleshooting and repair. Through thorough examination techniques, including checking for multiple related DTCs and performing continuity tests, knowledgeable technicians can pinpoint faults effectively. Understanding the interactions between components, such as the power seat adjustment switch, slide motor, and position sensor, is essential to troubleshoot correctly. By following the outlined steps and adhering to safety practices while handling electrical systems, resolving complex issues becomes manageable. Moreover, implementing preventive maintenance will greatly bolster the system's reliability, offering a consistently high-quality experience for drivers and passengers alike. Ultimately, the goal is to foster a safe and comfortable driving environment, free of recurring DTCs. Please like and subscribe to the channel. See you next time!